Hey everyone, and welcome to another Explainer. I'm so thrilled you're joining me today because, well, we're tackling a seriously fascinating transformation happening in the AI world right now. You see, basically every company out there is trying to implement AI, right? But they're quickly realizing that out-of-the-box, general-purpose models just kind of don't cut it for highly specialized, mission-critical tasks. So today we're looking at a framework presented by Codatta. We're going to explore the exact roadmap of how we take a foundational, generalist AI, which, don't get me wrong, is already incredibly impressive, and transform it into a highly capable, pinpoint-accurate domain specialist. Okay, let's dive right in and see exactly how this evolution happens. It all really boils down to one core question. How does a general AI actually become an expert? Think of a brand new foundational AI model like a brilliant, newly minted college grad. I mean, they're undeniably smart, they've read a staggering amount of material, and they possess massive potential. But if you drop them straight into a bustling emergency room or ask them to draft a complex corporate merger, they're going to struggle. Big time. Why? Because they lack domain-specific heuristics. They don't inherently understand strict regulatory guardrails, and they definitely haven't developed those niche problem-solving frameworks that take human professionals literally years to cultivate. Basically, they need to go through grad school. They need specialized training and hands-on experience to become reliable pros.
And the starting line for that journey is pretty straightforward. Knowledge plus data equals foundational AI. Think about the sheer scale of what it takes just to get to this point, right? We're talking about scraping vast swaths of the internet, crunching petabytes of data, running thousands of GPUs for months, and spending millions of dollars just to build the foundational chassis. It's an absolute mathematical marvel at predicting the next word for sure, but it's entirely untargeted. This foundational AI is essentially a mile wide and an inch deep. It knows a little bit about everything, but it hasn't yet mastered the rigorous intricacies needed to safely operate within one specific professional field.
So the contrast between these two states is just massive. General AI is inherently broad. It's designed to be a jack of all trades. It can whip up some standard boilerplate Python code or write a polite customer service email without breaking a sweat. But domain specialists, they operate in a completely different universe. Imagine moving from writing standard code to, say, reverse engineering the security architecture of a legacy banking system. A domain specialist AI needs to deeply understand the unwritten rules and highly technical dependencies of a specific industry. It has to solve problems with extreme, unforgiving precision where a single hallucination could literally cost millions of dollars. The broad, probabilistic guessing of general AI simply isn't enough for those high-stakes tasks. And that's exactly why we need a structured, rigorous process to bridge that gap. Codatta outlines a four-step educational journey to get us there. 1. Fine-tuning to shape internal logic. 2. RAG, to ground the model in facts. 3. Prompting to guide it without retraining. And 4. Evaluation to test real-world readiness. Let's break these down. Kicking things off with Phase 1, fine-tuning. This is all about shaping the AI's internal logic. This is a really active teaching process. We don't just hand the AI a massive new dataset and cross our fingers. Through fine-tuning, we're actively curating a diet of highly specific, high-quality info. We feed the model domain-specific examples, so it learns what good actually looks like in practice. We walk it through complex reasoning scenarios, so it learns how experts connect the dots. And absolutely crucial here, we train it on edge cases. Take autonomous driving, right? A general AI knows what a pedestrian is, but what if someone is crossing the street wearing a giant chicken mascot costume? Or in medicine, what if common symptoms are actually masking a remarkably rare drug interaction? Fine-tuning is where we feed the AI these weird, rare anomalies, so it doesn't just freeze up or guess wildly when it hits the unexpected in the real world.
The huge takeaway here is that we are fundamentally shaping the model's internal logic. For those of you deep in the technical weeds, this means we are literally adjusting the model's weights and biases. We're not just giving it new facts to memorize, we are mathematically altering the probability distributions of how it responds to niche domain prompts. So when it faces a complex problem, its internal pathways have been rewired to completely bypass those generic responses and tackle the issue exactly like a specialist would. This structural shift is really the heavy lifting of the whole transformation.
Moving right along to Phase 2, RAG, which is all about grounding our model in facts. RAG, or Retrieval-Augmented Generation, is kind of the ultimate antidote to a problem everyone in the AI space cares deeply about: hallucinations. Essentially, RAG is the process of curating trusted sources and verified facts that are used right at runtime to ground the model's outputs in reliable, human-validated knowledge. Instead of forcing the AI to rely solely on the static knowledge baked into its neural network, which, let's be honest, can lead to some very confident guessing, we connect it to a database of verified, proprietary corporate documents or medical journals. It's basically giving the model an open book test. It pulls accurate, highly relevant info in the moment, forcing the model to cite its sources and making sure its answers are always anchored in verifiable reality.
Now for Phase 3, prompting. This is how we guide models without retraining them.
You see, even with optimized weights and a database full of facts, our AI still desperately needs exact instructions. Prompting at this level isn't just a basic chat interface, it's a rigorous development discipline. We guide the AI using advanced techniques like chain of thought or few-shot prompting. We are explicitly giving the model the exact mental framework an expert uses. We define the persona. We lay out precise logic chains the model absolutely must follow before answering, and we provide strict task framing to constrain the output. We're effectively translating human expert intuition into systematic rules the model can execute flawlessly. And the immense value of this step, it literally cannot be overstated. Fully retraining a foundational model from scratch can cost millions of dollars and require months of intensive compute time. No thanks. By contrast, expert-level prompting lets us achieve highly specialized, nuanced behavior at a fraction of a cent per token. Just by changing how we frame the instructions and enforce logic constraints at the prompt level, we guide the AI to perform complex, niche tasks perfectly. It's a game changer, an incredibly powerful, cost-effective way to squeeze out that absolute final layer of specialization.
Which brings us to our fourth and final step, Phase 4, evaluation, testing real-world readiness.
Look, you absolutely cannot deploy a specialist AI without knowing for a mathematical fact that it can do the job safely. Evaluation is the critical feedback loop needed to continually improve these systems. It isn't enough for the AI to just sound smart in a sterilized testing environment. We need to systematically expose where it fails, where its logic chains break down, and where it ignores its RAG database to hallucinate. And here's why this is so important. Every single failure discovered in evaluation is fed directly back into Phase 1 as a brand new edge case for fine-tuning. It creates this beautiful, continuous loop of perpetual improvement. To do this effectively, we utilize deep human domain judgment. This involves industry concepts you might have heard of, like RLHF, reinforcement learning from human feedback, and rigorous red teaming. This is especially critical in high-stakes environments like research, strategic planning, and scientific domains. We aren't just having human experts passively grade a multiple-choice test here. We have top-tier professionals actively trying to break the AI's logic, tricking it, and pushing it to its absolute limits in simulated environments. Human judgment is the ultimate, uncompromising gatekeeper, ensuring the model is truly ready for the messy complexities of the real world.
So when we pull this all together, the transformation is remarkably clear. Domain knowledge is the key to the whole shebang. By teaching the model through fine-tuning, grounding it against hallucinations with RAG, guiding it with advanced prompt engineering, and ruthlessly testing it through evaluation, we successfully inject that crucial domain expertise. For the developers, business leaders, and AI enthusiasts watching, this is the exact blueprint you can leverage. This is how you take a general foundational model and build an incredibly powerful, deeply specialized expert for your own custom enterprise use cases.
I want to leave you with a thought to ponder today. We've seen that to build these incredible AI specialists, we absolutely rely on human-validated facts, human edge cases, and human expert thinking to train, ground, and test them. Every ounce of this specialization actually comes from human experience. So, the provocative question is this. As these tools become more and more capable, seamlessly executing highly complex tasks, where exactly is the line drawn between human expertise and AI specialization? Who is the true expert, the machine or the human whose hard-won knowledge powers it? Think about that. Thank you so much for joining me for this explainer. Keep learning, keep building, and I'll catch you in the next one.